Okay, so we're going to go back and just look at linear inequalities, and then I'm going to stick a system or two in here as well. So I think we may have done these already. I can't remember exactly because Mr. Fisher was in charge at that point. So let's make sure we can do the ones that are linear inequalities before we look at systems of inequalities. Okay? So just one line at a time. This guy's a line, right? Y equals mx plus b. Is it set up and ready to graph? Yeah, the only difference is instead of equals, less than or equal. Don't treat it so differently. Start by drawing a graph of the line. So where should I start? What number tells me where to start? The -5. So start right there. That's the y-intercept. And from -5, where should I go? So slope is rise over run, up 2 over 1. If there's not a 1 there, write it. So up 2 from there over 1. And now instead of just drawing my line really quick, I'm going to look at the symbol and it says less than or equal to. So what do you guys think? Is it going to be solid or dashed?
Solid.
Is it equal to or not? That says solid. That says the edges of this region will count. But the things that are solutions are not just the things on the line this time. This says it wants things equal to the line or less than the line, which means below the line. It wants the y values less than. So that's different in different situations. Where do you guys think is less than the line? Below, which is in this case, this line is to the right-hand side, right? So we're thinking about over here. Have we done this before this year? I think we may have done it slightly. If not, oh well. So this is the solution region over here. That's it. It's the solution region. The edge counts, the boundary is part of the solution region, and anything below it. Any point over here will come out correctly. Now some problems, they're not going to ask you to draw it, they're just going to ask you to test some points. So they might come along and say, here's a couple test points. They might ask us to test -2, 4. They might ask us to test 6, -3. And they might say, are those solutions to this inequality? Well, it's pretty easy to test them. You can use your graph, or you don't even have to use your graph. How you do that's up to you. I don't care, right? What do you guys think? -2, 4. Looking at the picture, is it an answer or not? -2, 4. Is it in the shaded region? Clearly not. Not an answer. What would that look like with algebra? Plug it in. Say the y value is 4, less than or equal to 2. What's the x value? -2 minus 5. Simplify. -4 minus 5 is -9. Is 4 less than -9? I don't think so. That tells you it's not an answer. Yeah? What do you guys think? From the picture, 6, -3. Is it looking good or no? My picture's not perfect, right? But like 1, 2, 3, 4, 5, 6, -3. That's like somewhere down here. I'm thinking it's good. Let's check. And take it and plug it in. Y value is? Points go x, y, right? All right. Y less than 2x minus 5. Let's see if that works. Is -3 less than 7? Ka-ching. Yes, that's true. Makes sense from our picture too, right? So how you do those kinds of problems is up to you. I don't care. Draw the picture, you can test it. Do both.
So it says -3 is less than or equal to 7. Is that?
Is it less than or equal to 7?
It's less than, but it's not equal.
But less than or equal to 2 means less than
Okay.
or equal to. Very good question, Logan. It doesn't mean and. It means or. One or the other. Technically, that's the way that sign works. Very good. It's a subtlety. Ms. Collins?
But technically, that would be physically impossible because you can't be equal to and less than something.
Right. So that would make ridiculousness if you used an and symbol there. That's a very good point. Nice. Good question. So she's saying logically, Logan, come on. But that's good. It's a very good question. I like the sassiness. It's good. All right. So let's try this one. So ready to graph, guys? Why not? I gotta do So got to solve for y first on this guy, right? Not quite by itself yet until we
Divide by 2.
divide by 2. So this one says y is bigger than negative 4 minus 5 halves x. I think that's ready to graph. We won't test any points this time, but let's plot it starting with, where should I go first, Joe? Should I use the 4 or the 5 halves? That's the slope though, isn't it?
Yeah.
So where should I go with negative 4? Like this way, up, down, right, where? Down. Right there, right? And then from there, where should I go, ladies and gents?
Down 5.
Slope says go down 5 over 2. So down 5 more. 1, 2, 3, 4, 5 over 2. Something like that. What do you guys think? Solid or dashed line on this guy? It doesn't say equal to, so it's dashed. And should I shade above or below?
To left.
It says bigger than. Where is bigger than on this line? Is this part bigger than this part, this part, this part? Bigger than really means above because it says it wants the y is bigger than, y is vertical, right? So I want the above parts, which is to the right. Those are all above the line. Okay, if we wanted to test some test points, we could. Let's just leave it this time, I think. All right, why don't you guys try that one while I cook up 1 or 2 more, and we'll add a system now. Okay, so try that guy. Watching the video, you pause it and try that out. All right, so let's have a look at this. Is it ready to graph right away? No, I gotta move stuff, right? I'm just gonna go ahead and do that. You guys seem pretty comfortable with it mostly. So I'm gonna go minus 4x, and I'm also gonna move the 3 at the same time. So I'm gonna get negative y is left, minus 4x minus 3. A couple people as I was going around asked me a question. They said, that's negative y. It's kind of an issue. You don't need negative y, you need y. What do you have to do?
Can you just move the y?
You could. That's another smart way to do this problem. You could just add the y to the other side, and you'd have it done, kind of, wouldn't you? That's smart. But I'm going to do it this way just because this is going to come up inevitably on some other problems. You guys are smart. Very nice. What could you do in this case, though? To get rid of the negative, you
divide and then you have to switch the sign.
divide it. And on this one, yes, there's definitely a much smarter route to the problem. Just add y to begin with, and it's ready to go. But sometimes you're going to have to divide by a negative number. And when you divide by a negative number with inequalities, remember, inequalities are like thinking about all the things this way and all the things that way. What's that mean you have to consider? Slong? Watch. I have to do what with the sign? I have to flip it if I divide or multiply by a negative number. So that's 4x now and plus 3. And I think if you think about this, think about what those two suggested a second ago. If I add y to the other side, think about it in your head. Will you get y is greater than 4x plus 3? Yep. So, same thing. All right, let's graph it and be done. I should start with the intercept up 3, and then this says go up 4 from there, so to 7 over 1. Solid line, right? Because it's equals, and shade above or below? Above. I like shading above for some reason here. I don't know. So above this time I think is to the left. So those are the solutions this time. All right? So let's look at a couple systems. Because I gave you problems out of 2 different sections. Some of them have systems, some of them don't. Now we're looking at 2 inequalities at the same time. I don't think the strategy should be so different until the very end. Do them separately. These are both ready to graph. I bet you guys forgot how to do these, and that's not good going into Algebra 2, so definitely good we're reviewing this right now. These are not mx plus b lines. There's 2 other forms, special forms of lines. You need to remember those. So I saw Ms. Collins out there is going like this and like this. These are horizontal and vertical lines. Which one is which? So that's good, and that's what I used to think too. That's why it confused me, Caden. I used to totally think like y is vertical, right? I agree with him. And x is horizontal. That's a great way to think, and it will help you a lot in trig and stuff, Caden. It's great. But that's not exactly what these are saying.
You're saying that the y coordinate's always -6. So
See, this is saying the y coordinate is always less than or equal to -6. If the y was just equal to -6, where would it always be equal to -6? 1, 2, 3, 4, 5, 6. There's one spot it's equal to -6. Where's another one? This way, or this way, or anything like that. So that can be a little bit confusing if you just try to memorize it. Caden wasn't just memorizing it. He was thinking about whether it was horizontal or vertical. That's a lot better. And y is vertical. But this says make the y's all be less than a certain amount. So that means vertically think below that horizontal line. Okay, so you have to memorize that for yourself one way or another. So I think that is down below here, right? Same thing with the x's. This says the x's are always bigger than 2. Here's one x that's equal to 2. Where's another one? There or here. That's a vertical line. That's x equals 2. And where would the x's be bigger than 2?
And above the 2.
To the right. So this starts to get a little bit messy. If you want to use 2 colors, great. Now, the system bracket, this guy says simultaneously, where are those both satisfied? So can you guys describe to me, where are they both satisfied? Down here, right? Where they overlap. So you want to shade that in darker with your pencil. That'd be a great way to do it, shade it in darker. I think both edges count. Sometimes one might be transparent or dashed, so make sure you're careful. This area down here should all be shaded in darker. And I think there's still, how many answers to this problem? There's still an infinite amount down here going this way, and then they're going that way, and etc. That's still an infinite plane of things. Okay? Let's do one more of those, then we'll do some matching and call it good. So this one, the first line looks ready to go to me. I'm going to be a little bit less crazy. This time I'm not going to shade as much. How you do it's up to you. Let me show you an alternative if you don't like being messy. This line's ready to go. Going down 1, right? And from there I should go up 1 over 3. 1, 2, 3, something like that. It's a nice simple line. I'm going to shade above or below it? Above. This says it wants the bigger y's. So we're going to be up here already, right? The other line we've got to do a couple things to solve, so I'll do that. Subtract this. Divide the negative like in our other problem. Could be smart again, like Mr. Kirkendall is saying, but I'm not smart sometimes. It happens. If I divide by negative, gotta flip. Alright, that one's ready to graph. Do it in red. Dashed or solid this time?
Dash.
Doesn't say equal to, so the edge doesn't work. So I'm going to go down -5. From there, I'm going up 3 over 2.
You need to go up 1. You need to go up 1.
Oh, did I make a mistake? Did I go from here? Nice. 1, 2, 3, 4, 5. Thanks, Richard. There we go. Up 3 over 2, something like that. Now, you can shade these both. Like I said, that's one option you have. I don't like that so much because it makes me crazy. It's too messy. It's an easier way, though, I think. Or you can just think about it. So, we're supposed to be above that line. It says greater than. So above the blue. And this says above or below? This one also says above the red line. So where is it going to be both above the red line and above the blue line? Like the top left, great. This is going to be above the red and blue, right? How about here, above red and blue? It's not above the blue. How about over here, above red and blue? It's only above the blue. How about here?
Yeah.
Yes, so I think Richard was trying to say this region up here only up to this edge, right? So one edge of this region is solid, one boundary is solid, one is transparent. These points on the edge count as answers. These points on the edge are not answers to the system. Okay? So there you go, how to do systems. Let's play matching once or twice. So I would like... So you'll also have some problems that ask you to write down a system that is pictured for you, or to write down just an inequality that's pictured for you. So what do you guys think for that left one? How would I do that? I think you just use what you know about lines. That's all you've got to do. So mx plus b, let's think about it. So we'll get y going in there. What do you guys think, above or below for this one? We're going to shade above or below or what? Below, so should we put less than, greater than? It's less than. Should I put equal to on it or not?
Yes.
It's solid, so less than or equal to, and then you got to think, okay, what's the y-intercept? -3. Right there. And the slope on this guy, you got to look in the graph to you can see 2 points. I usually like to go from the y-intercept. Looks like up 1 over. Yeah, very nice. I tried to draw that nicely. You can see it, huh? Up 1 over 7 was what I was going for. So 1 over 7 x, because the slope is always attached to x. There you go. That's it. And this isn't a system because there's just one line. I think you'll have a lot of those. Yeah. So here's the system. How many pieces are in this system?
3.
This is 3. I don't know if any of yours have 3, but we certainly use that in other classes. So we might as well just do 3. They're all lines. So let's see. Which one do you guys want to do first? One of the solid lines?
Let's just solid lines. Doesn't matter.
Dotted line's actually easiest, but you guys haven't used it as much. So let's do one of the solid ones. Let's do this one, the top one. What's its equation?
Y is less than
Less than, because it's below,
2
or equal to.
j.
Its y-intercept is
2.
2. Put 2 first if you want. Its slope looks like from here to here goes up 3 over 1. So plus 3x, something like that. Work, right? Right, that's that blue line. How about this solid blue line? You're going to be above or below it? Above. I think it's solid. Y-intercept is -10. You can write that first or second. It's up to you. Slope goes, I tried to go
Is it up 1 over 1?
up 1 over 1. I tried to draw, so we'll just say x -10. Done. Make our little system bracket be a little bit bigger because this is a system of 3 inequalities. And the last one, we've got a special line, x or y?
X.
X, because the x's are the same on this line. All the x's are what on this line? They're all negative, positive 8. Yeah, positive 8. And are we wanting the x's less than or more than 8?
Less than.
We want them this way, right? That's less than 8. And I don't want to fill this in because it's dotted. Boom. That is that picture. On your computer, you can even experiment. Grapher will draw this picture for you if you enter this kind of a thing. Maybe we'll do that next week. And we'll also throw in some parabolas next week and start making more complex systems. Okay? With some other functions. But you've just got lines going on right now.